Fourier transform. Now we will go through the Fourier transform. So what is Fourier transform? So where it is used and any conditions and the properties of Fourier transform. Fourier transform of different signals like basic signals and standard signals. So Fourier transform. See, Fourier transform is derived from Fourier series, because in Fourier series one small limitation is there. In Fourier series one small limitation is there. That limitation is frequency domain representation of Fourier series is always discrete. It is always discrete and it gives the infinity number of frequencies. And Fourier series is generally used to convert or to separate DC and AC frequencies. DC and AC signal separation purpose Fourier series is used, and that is specifically defined for periodic signals. If the signal is a periodic signal means the signal is defined in particular time period. It is not a repeated function. It is not a repeated signal. For those type of signals, separate transform is introduced. That transform is a Fourier transform. This is derived from the Fourier series, exponential Fourier series. Now I am writing one standard equation. Fourier transform of, see now one words I am writing like this, ft, it explains the Fourier transform, right? So Fourier transform of x of t is x of omega, or sometimes we can write x of j omega. The representation is we can write either x of omega representation or x of j omega representation, both are same. So every time writing j is difficult, that's why now onwards we have to prefer this representation, but both functionality, equation and everything both are same here. So either we can write like this or like this. Fourier transform of x of t. X of t, x function is changing with respect to time. X function is changing with respect to time, that means this is time domain function here, right? So this is time domain function. And x of omega, x function is changing with respect to frequency, this is frequency domain function. So to convert time domain to frequency domain, here we have to use one standard transform. This transform is Fourier transform. Laplace transform is also converts the time domain to frequency domain, but Fourier transform gives the frequency responses of the signal. Frequency response is nothing but it is the combination of magnitude response and phase response. That is the main aim of the Fourier transform. So now I am writing that point here. Fourier transform is used to find frequency responses of the signals or systems. Frequency responses of signals or systems, or we can write as a function, signals or systems. So what is frequency response here? Frequency response is the combination of magnitude response and phase response. Just now we have discussed the magnitude of the system is changes with respect to frequency axis. With respect to frequency axis. This response is also called as magnitude response. Sometimes it is also called as amplitude response. It is also called as amplitude response. And phase of the system means angle. Angle of the system is changes with respect to frequency. This response is also called as phase response. Phase response, or sometimes we can call it as a angle response. So the combination of these two is called frequency response. Now we have to discuss magnitude and phase response of different signals using one standard transform, that is Fourier transform. So first of all we will go through the mathematical equation of Fourier transform. Fourier transform of x of t becomes here x of omega, or we can write x of j omega, which is used to convert time domain to frequency domain. So this is used for a periodic signal, that's why here we have to write integration is from minus infinity to plus infinity. Integration gives the area of the function, because this is specially defined for continuous time signals. Here completely we have to find out the area. So according to that, here we can write integration from minus infinity to plus infinity, x of t into e to the power of minus j omega t dt. This is one of the standard equation. Please remember this equation. So Fourier transform of x of t is Fourier transform of x of t. This is time domain function. It's also called as input signal, right? So now this signal we have to write as it is here. So whatever the function here, write this function as it is here into e to the power of minus j omega t dt. This explains the standard equation of Fourier transform. And Fourier transform is used to convert time domain to frequency domain. Here the limits are from minus infinity to plus infinity because Fourier transform is specifically defined for aperiodic signals, non-periodic signals. That's why here we have to write always integration is from minus infinity to plus infinity. Now we will go through the standard functions, how to apply Fourier transform of the given signals. First of all, I am taking one basic function. This basic function is x of t is equal to e to the power of minus at into u of t. X of t is e to the power of minus at into u of t. See, to find the Fourier transform of any function, first of all we have to check one condition. That condition is, if the signal is energy signal or stable function, then Fourier transform is applied. Then Fourier transform is applicable. Otherwise it is not applicable, right? So if the signal is energy signal or stable signal, then the Fourier transform is applicable. So for that purpose, first of all we have to find out whether the signal is energy signal or not. If it is energy, then only Fourier transform is applicable. So don't apply directly this equation. This equation is valid if x of t function should be energy signal or it should be stable function. So how to find out whether it is energy or stable function? So to find that purpose, already we have discussed a few techniques in classification operations on the signal, classification of signal. Those techniques are like a Bibo stability condition or substitute t tends to infinity in this equation. Depends on these limits here. Depends on these limits. We have to substitute infinity time period, whether it is minus infinity or plus infinity, that is depends on this u of the representation. So substitute that one. If the amplitude is 0, if it is goes to the 0, then it is a energy signal. So according to the analysis, just I am writing few points here. Fourier transform is applicable. Fourier transform is applicable for energy or stable signals, energy or stable functions. It is not applicable for non-energy signals and unstable functions, right? And to find the energy or stable function, here we have to apply like this. Apply limit, t tends to, apply t tends to infinity or t tends to minus infinity. If the function is u of t function, if the function is defined with u of t representation explains the time limits are changes from 0 to infinity. From that we have to take large time period, that is t tends to infinity, right? And if the function is u of minus, if the function multiplies with u of minus t limits are minus infinity to 0. What are the limits of u of t? 0 to infinity, right? So if any function is multiplies with u of t, immediately we have to substitute t tends to infinity in that, Otherwise, if the function is multiplies with u of minus t, then immediately we have to apply t tends to minus infinity. Then if the amplitude is 0, then it is called energy signal. Or stable function. First of all, we have to apply this analysis here. So for that purpose, here I am substituting. See here, the given function is multiplied with this function here. U of t is there. Unit step function. Time limits are defined from 0 to infinity. That's why here I am substituting t tends to infinity in that equation. Plus infinity, not minus infinity. So minus infinity is applicable if the function is multiplied with u of minus t. So I am substituting t tends to infinity in that. E to the power of minus a into infinity, then becomes e to the power of minus infinity. E to the power of minus infinity is 0, right? So e to the power of minus infinity is 0, then the signal is energy signal. Then Fourier transform is applicable here. First of all, I want to draw the graphical representation of this function. X of t function changing with respect to time axis. So what are the time limits of the given function? Time limits of the given function is explained from using this representation u of t. U of t explains this function is defined from 0 to infinity. So that's why here we have to take time limits are from 0 to infinity. Just take time limits are from 0 to infinity. This side the function is not defined, that's why we have to draw like this. Negative time axis side the signal is not defined because the function is multiplied with u of t. Please remember that point. If any function is multiplied with u of t, this complete signal is defined from t is from 0 to infinity. Only positive time axis side it is defined. Other than the positive time axis it is not defined. Now within this limits here this function is exponentially decreases, right? That purpose I am substituting t is equal to 0 in this. If you substitute t is equal to 0 in this, it gives the e to the power of 0. E to the power of 0 value is 1. So exactly at t is equal to 0, the amplitude of the function is 1. And time axis is increases, the amplitude of the function is exponentially decreases. It should be like this. And finally it becomes 0 at t tends to infinity. At t tends to infinity, this amplitude becomes 0. This is exponentially decaying function e to the power of minus at. And remember one more important point. If any signal in a long time period, if any signal amplitude goes to the 0, if the signal amplitude goes to the 0, then the signal is directly, we can write it's an energy signal because it has finite area. It has finite area. That's why the signal comes under energy signal. From the graphical representation, if you want to find out energy or not energy, that purpose, please check the signal. If the signal amplitude goes to the 0, if the signal amplitude goes to the 0 within a long time period, then the signal comes under energy signal. Otherwise, it's not energy signal. Now the signal is energy signal. Here we can apply Fourier transform. So how to apply Fourier transform I will explain next video. So here I have explained just introduction to the Fourier transform. So please take this.